Hi, boys and girls. I'm going to go ahead and do a lesson with you today in a flipped style. So I'm going to show you our objective and how to use it today, and then I'm going to give you time to work. So the goal of this lesson today is to show you that you can check the reasonableness of your answer using estimation. We worked on estimation for about 2 weeks, so I feel pretty confident that you're pretty good at that skill already. So now how can we use it to make sure that our answers are reasonable? Or do they make sense? So I'm going to give you some of the examples in addition and subtraction. So here we go. In this problem, 25 plus 41, we can use estimation before we do any calculation. You can also do the calculation first and then estimate. Either one is fine. What I'm going to do here is I'm going to round to the nearest 10, basically just because that will give me the nearest number to the greatest place value, since these numbers, the greatest place value is the tens. Typically, I do try to stay with the greatest place value when I'm doing 2, 3, or 4 digit numbers. When they get a little bit bigger, might want to be a little more precise. With the place value, I choose to round to. So I'm going to round to the nearest 10. So I know that 25 on a number line rounds to 30. I know that because it's only 5 away from 30 on a number line. I also know that there's that little rule: if a number is 5 or more, raise the score; 4 or less, let it rest. So I know that this is going to round up to 30 rather than down to 20. Although if you use 20, it would still be okay. I'm also going to round 41 to its nearest 10, and it rounds to 40. So then I'm going to add 30 plus 40, or 3 tens plus 4 tens, and get 7 tens. So I know that the answer to this problem should be about 70. Now I am going to talk to you a little bit about that this is an overestimate. And I know that because I rounded this number up 5 and this one I only rounded down 1. So the change with these two estimated numbers is making them larger than they would have originally been. So I know my answer is actually going to be a little bit less than 70 because this is an overestimate. All right, so now I'm going to use standard algorithm to add 25 plus 41. I'm also going to show you another way. So I'm going to add up the ones. 5 ones plus 1 1 is 6 ones. And 2 tens plus 4 tens is 6 tens. So I got an answer of 66. Now I ask myself, does that make sense, or is it reasonably close to the number 70? And it is. Another way I could answer this problem is to make an open number line and start with 41. I chose the greater number because I know I can change the order of addition and it's okay. And then I'm going to make a jump of 20 and then a jump of 5. Okay, so I can show that using an open number line like this. So that's one way I can use estimation to check the reasonableness of my answer using estimation. So I've used standard algorithm and an open number line to solve the actual problem. Okay, now I'm going to show you with a number, or with a problem, excuse me, in the hundreds place rather than just in the tens. I'm going to start with this problem, 389 plus 925. Okay, so I'm going to round each of these numbers to the hundreds place because, again, I'm going to round to the nearest greatest place value, which in this case, the greatest place value in both number is 1,000, or in the hundreds. All right, so 389 rounded to the nearest hundred is 400. And 925 rounded to the nearest hundred is 900. So now I'm going to add 900 plus 400, or 900s plus 400s. So I'm actually going to break that into 3 and 1. So I can have 900 plus 100 is 1,000 plus 300 more is 1,300. So I know the answer to this problem needs to be about 1,300. Now this one is a little bit more difficult to say if this is an overestimate or underestimate because I changed both numbers quite a bit. To go from 389 to 400, I know that's 11 hops on a number line. But to go from 925 down to 900, I went down 25 hops. So since this number is greater, it's an underestimate because I went down more than I went up. So my actual answer is going to be a little bit more than 1,300. Okay, so now I'm going to use standard algorithm to add these together. 9 ones plus 5 ones equals 14 ones. But I can't write 14 in that place value, so I'm going to regroup this 10 and 14 and put it above the tens column. Now I have 8 tens plus 2 tens, it's just 10 tens, and another 10 is 11 tens. Well, I can't write 11 here, so I'm going to regroup that and put it on top. So now I have 1 100 plus 3 hundreds plus 9 hundreds. So I'm going to say 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my actual answer is 1,314, which is a little more than my estimation. So now I know that that answer is reasonable. Okay, so I've shown you how to do this, a standard algorithm. Let me also show you how to answer 925 plus 389 another way. This time, instead of doing a number line, I'm going to show you how you could use place values. So I'm going to do 925 and then I'm going to break apart 389. So I'm going to do plus 300 plus 25. Oh, just kidding. Shoot. Plus 80. I read the wrong number. Plus 9. Okay, so I would get the same answer if I take 389 and I add it to 925 by its chunks. Okay, some kids also like to do 300 plus 900, 80 plus 20, 9 plus 5. So they took the expanded form of each number and added them up by their place values that way. And that way would work as well. That way might actually have been the easiest for me looking at these choices. Okay, so this is how you would do addition. And now let me show you a couple of examples in subtraction. All right, the first problem we're going to start with is again in the tens. We're going to do 39 minus 11. Okay, I'm going to round 39 to the nearest 10, and it's almost 40. And then I'm going to round 11 to its nearest 10, which is about 10. So I'm going to make this problem about 40 minus 10, which is 30. So now I'm going to do standard algorithm and an open number line, two different ways, and see if my answer is about 30. So I'm going to start with, let's do 11 and count up to 39. So first I'm going to count up to 19 and I'll show you why. I'm going to say 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, so that would be adding 8. Now I'm going to go 29, 39. So I'm going to add 10 and 10. All right, so if I have 8, 10, and 10, I get an answer of 28. So that's a way you can use an open number line and solve this problem using addition. Most kids say they like addition better, so why not? Now, would that be true? 28 plus 11 equals 39? That looks right. Now let's try it another way. Let's do standard algorithm, 39 minus 11. We'll start in the ones place. 9 minus 1 is 8, and 3 minus 1 is 2. And either way, I get the same answer, and 28 is very close to 30. So my answer is reasonable. All right, last one, boys and girls. 219 minus 115. Again, I'm going to round to the greatest place values in each of these numbers. That's the hundreds place. So I'm going to round 219 to the nearest hundred and 115 to the nearest hundred. And 2 hundreds minus 100 is 100. Okay, now I'm going to answer this problem and see if my answer is about 100. I think for this one, I will start again with an open number line and use addition. So for that to work, I start with the lesser number and I count up or add up until I get to 219. So I'm going to start with 115, 16, 17, 18, 19. I'm going to jump up 4 to land on 119. And if I want to go from 119 to 219, I jump up 100. So I think the answer to this problem is 104. Is 104 reasonably close to 100? Yes. Now I can use standard algorithm as well, and I should get the same answer. Let's try it out. 9 ones minus 5 ones is 4 ones. 110 minus 110 is 0 tens. And 2 hundreds minus 100 is 100. And since 104 is about 100, that is a reasonable answer. Boys and girls, these are some examples of ways that you can check the reasonableness of an answer in addition and subtraction using estimation.